Hi, I'm Miss Hearn. Let's get started. In this video, we're going to talk about how to find the complement of a graph in graph theory. In graph theory, one graph is the complement of another if any vertices that are adjacent in one graph are not adjacent in the other, and vice versa. So, for example, we have here a graph on the left in which A is adjacent to B, and on the right, A is not adjacent to B because there's no edge between them. In the left, B is adjacent to C, and on the right, B is not adjacent to C. There is no edge between them. On the left, C is adjacent to D. On the right, C is not adjacent to D. On the left, there is no edge between A and C. They're not adjacent, but on the right they are. On the left, there is no edge between A and D, but on the right there is. And then on the left, B and D are not adjacent, but on the right they are. So these two graphs are complements of each other. We can also say they are complementary graphs. A complete graph is a graph in which each pair of vertices is connected with an edge. In other words, every pair of vertices is adjacent. Together, any two complementary graphs form a complete graph. One fills in the missing edges of the other. This gives us a way to find the complement of a given graph. The first step would be to draw the complete graph with the same number of vertices as the graph you were given, and then just remove all the edges that were in the original graph. Whatever's left is the complement of the original graph. For example, let's find the complement of this graph. First, I'm going to draw all of the vertices. Then I'm going to connect every pair of vertices with an edge so that I have a complete graph. So G will be connected to all four of the other vertices. F will be connected to all four of the other vertices. J will be connected to all four of the other vertices. I will be connected to all four of the other vertices, and so will H. From this new complete graph, I'll remove any of the edges that existed in the original graph. So for example, from G to F, I will remove. From F to J, I will remove the edge. From J to I will remove the edge. From H to J, I will remove the edge. And from G to H, I will remove the edge. What's left is edges that did not appear in the original graph. So these two graphs are complements. The complement of a graph can be useful in many contexts. Let's look at this example. In the given graph, edges represent the direct flights between cities A, B, C, and D. We're going to create a graph in which an edge between two vertices indicates that the cities do not have direct flights. So it kind of gives us the opposite information. One graph shows the pairs of cities between which you can get a direct flight. The other is going to show the pairs of cities in which you cannot. Those will be complements of each other. We'll take the same approach as before. We're going to draw each of the vertices. Although it's not necessary to keep the vertices positioned in a relatively similar way, because all that really matters is the connections, not where you draw the vertices, I find it's helpful to keep them kind of similar. And then I'm going to make a complete graph out of them by connecting every single pair. So A is going to go to B, to C, and to D. B is going to go to A, to C, and to D. C is going to go to A, to B, and to D. And D is going to go to A and B and C. All right, so we have a complete graph now. And then I'm going to remove any edges that existed in the original graph. So I'm going to remove A to B. I'm going to remove A to C. I'm going to remove A to D. And I'm going to remove C to D. Okay, and what's left is a graph that shows which pairs of cities do not have direct flights between them. So there's no direct flight between city B and city C, and there's no direct flight between city B and city D. Notice that there's no city that city A doesn't have a direct flight to. This is the complement of the original graph. I hope you found this video helpful. If you did, please give it a thumbs up. That helps other students to find the video. You can also subscribe to my channel, Miss Hearn Mathematics, for more math videos.